Hello and welcome back to Engineers Olympiad. We are doing the numerical questions for the topic weight volume relationships in geotechnical engineering. This is the video lecture number 3. We have already put up two video lectures for the same topic on this channel, Engineers Olympiad. You can watch those videos before watching this video. So let's get started. Question is: a compacted cylindrical specimen, 50 mm diameter and 100 mm in length, is to be prepared from oven dry soil if the specimen is required to have a water content of 15% and the percentage air voids of 20%. Calculate the mass of the soil and water required for the preparation of the sample. We have to take specific gravity as 2.69. Alright, so this is the question and we'll be solving this. So let's get started. Alright, so the question says that a compacted cylindrical specimen which is 50 mm in dia and 100 mm in length is to be prepared from oven dry soil, and this specimen is required to have a water content of 15% and percentage air voids of 20%. We have to calculate the mass of the soil and water required for the preparation of this sample. All right, so let's get started. We know that water content it is equal to water mass of water by mass of solids. All right, so I can derive a relationship. Mass of water is water content multiplied by mass of solids. All right, so mass of water is how much is the water content. If the specimen is required to have a water content of 15%, so my water content is 15%, that means 0.15 multiplied by mass of solids. Let me suppose this is equation first. All right, we also know that volume of solids is given by relation mass of solids divided by specific gravity and density of the water. That means volume of solids is mass of solids divided by specific gravity. In the question we have been asked to use take G as 2.69. So we'll be substituting the same value 2.69 multiplied by the density of water, that is 1000 kgs per cubic meter. All right. Now volume of solids is equivalent to mass of solids divided by 2690 cubic meter. All right, this is the volume of solids. Volume of water is equivalent to how much? We'll use this equation number 1, mass of water, that is 0.15 multiplied by mass of solids. I have used equation first, which we derived in the very beginning, that mass of water is equal to 0.15 multiplied by the mass of the solids. So volume of water in this case will be mass of water, which is given by equation number 1, divided by the density, that is 1000 kgs per cubic meter. All right, so this comes equivalent to 0.15 into 10 raised power minus 3 mass of solids, and the unit is cubic meters. All right, so I calculated volume of solids by this equation, and I calculated the volume of water, which was equivalent to mass divided by the density. All right, moving on. So I have mass of water, which I calculated in the very beginning by this relationship, And then subsequently I found out the volume of solids and the volume of water. All right. Now, how much is the total volume of sample? Total volume of sample. Let's get back to the question and see what the question says carefully. A compacted cylindrical specimen, 50 mm diameter and 100 mm length. So this is a cylindrical specimen. We have to calculate the volume. Volume will be equal to pi by 4 d square multiplied by h. All right, or L in this case. So I'll be substituting the values. Pi by 4, how much is the dia? Dia as given in the question is 50 mm in dia and 100 mm length. So this is 50 mm, which is 0.05 meters. All right. Length is 100 mm, that is 0.10. By calculations, my volume, the total volume of this cylindrical specimen comes equivalent to 196.35 into 10 raised power minus 6 cubic meters. This is the total volume of this cylindrical sample. All right. After that, percentage air voids. Percentage air voids is a ratio denoted by N, this A, and it's a ratio between volume of air to the total volume. All right. Let's come back to the question. We have one more thing that's given. As per the data in the question, if the specimen is required to have a water content of 15% that we used, and we subsequently derived the volume of solids and the volume of water, and percentage air voids of 20%. All right, it's in itself given in the question. It says that the percentage air voids is 20%. So let me substitute over here. Percentage air voids, as you know, it's a ratio between volume of air to the total volume, and it is equal to, as per the data given in the question, it is 20%. So volume of air is equal to 0.20 multiplied with total volume. This is my relationship number 2. All right, as it was given in the question that the percentage air voids is 20%, and we very well know that the percentage air voids is a ratio between volume of air to the total volume, and I used the same equation and I derived volume of air, which comes equal to 0.20 multiplied with the total volume. All right, so let's substitute values. VA is equal to 0.20 into total volume of the sample, which we just calculated a while before, and which is equal to this 196.35 into 10 raised power minus 6. All right, so VA is, as per calculations, it's equal to 39.27 into 10 raised power minus 6 cubic meters. This is the volume of the air. All right, so if you can see, I just calculated 3 volumes. First, I calculated the volume of solids. Then I calculated the volume of water. And then subsequently, as per the data given in the question, I calculated the volume of air. So the total volume of the sample is equal to volume of solids plus volume of water plus volume of air. All right, the 3-phase soil system. So the total volume is equal to summation of the 3 volumes of soil solids, water, and air. All right, so I have all the 3. I'll be substituting the values, and I'll subsequently find the one thing, that is mass of solids. All right, So let's find out. Total volume, how much? 196. See carefully. 196.35 into 10 raised power minus 6 is the total volume of the cylindrical specimen, and it's equal to the summation of the three volumes of solids, water, and the air in soil three-phase system. All right. Volume of solids, we calculated this much. ms divided by 2690 cubic meters. Substitute the same value in equation 3, I'll call it. So it is ms divided by 2690. Then comes the volume of water. This much. 0.15 into 10 raised power minus 3 ms. Then volume of air, which is this, 39.27 into 10 raised power minus 6. All right. Now I'll do certain calculations and go on finding my mass of solids. See carefully. 39.27 into 10 raised power minus 6 minus 196.35 into 10 raised power minus 6 plus this thing plus 0.15 into 10 raised power minus 3 ms. All right. So by further solving it into 10 raised power minus 3 ms is equal to how much? This is minus 157.08 into 10 raised power minus 6. So I'll take this common over here, ms. It is 1 by 2690 plus 0.15 into 10 raised power minus 3. It is equal to minus 157.08 into 10 raised power minus 6. Minus and minus will go, and we'll be left with upon further solving this equation, it is 157.08 in 10 raised power minus 6. All right. So by solving mass of solids, it is equivalent to 0. Upon further solving this, it comes equivalent to 0.301 kgs. All right. By solving this equation, mass of the solids, it comes equivalent to 0.301 kgs. Now let's get back to the question and see what exactly we need to find. Calculate the mass of the soil and water required for the preparation of this sample. That means we have to just find, our aim of the question is to find mass of the soil and the water required for the preparation of this sample, that is mass of water. First thing we have calculated. Now mass of water. How much water will require to prepare this cylindrical soil specimen as per the data given in the question. All right. Now let's get back to the equation number 1. Mass of water is related with the mass of soil solids. By this equation, mass of water is 0.15 into ms. We'll use the same and go on finding the mass of water. It is 0.15 times ms. That means mass of water is 0.15 into ms, which we just found out, 0.301. By calculations, this is equal to 0.045 kgs. So this is how we solved this question, wherein we were given certain data and with regard to a compacted cylindrical specimen which had certain dimensions, and then it was to be prepared from oven dry soil, and we already had certain parameters as that of water content, which was 15%, and the percentage air voids, which is 20%, and we go on calculating the mass of the soil and the water required for the preparation of this sample. All right, so let's move on to the next one. This was a good question indeed. Now let's see what is the next one. All right, so the next question is: a sample of wet soil has a volume of this much and a mass of 32 kgs. When the soil is dried in an oven, its mass reduces to 28.5 kgs. We have to go on determining, all right, a lot of parameters: bulk density, water content, dry density, saturated density, void ratio, porosity, and the degree of saturation. All right, so let's solve this question. So the question says a sample of wet soil has a volume is given as 0.0192 cubic meters. A sample of wet soil has a volume of this much and a mass of 32 kgs. Mass wet 32 kgs. Then the question says, when this soil was dried in an urn, its mass reduced to 28.5 kilograms. Dried condition, how much? 28.5 kgs. That means mass of water is how much? Total wet minus dry, which is equal to 3.5 kgs. So this is the total mass of the soil when it's in wet condition. Then after drying in oven, its mass is 28.5 kgs. So subsequently I found out the mass of water, which is equal to 32 minus 28.5, and which comes equal to 3.5 kgs, and we know this is the mass of soil solids in dried condition. This is the mass of soil solids. All right, so I have to go on finding certain parameters. The first one is the bulk density. All right, we know that bulk density is equal to mass per unit volume, but which mass? Mass in the wet condition or the moist condition. So it is 32 divided by volume is same, 0.0192 cubic meters. So by calculations, my bulk density is, because that is the first parameter we have been asked to find out, the bulk density. So by calculations, it is equal to 1666.67 kgs per cubic meter. All right, next part. So we have calculated the bulk density. Then we have to calculate the water content. Water content is equal to mass of water divided by mass of soil solids. Mass of water, as we calculated in the very beginning, 3.5 kgs. Mass of soil solids, 28.5 kgs. By calculations, water content is 12.28%. All right, so part B is also completed. We calculated bulk density, we calculated water content. Then we have to calculate the dry density. All right, dry density is also equal to mass upon volume, but which mass? In the dried condition, that is the mass in the dried condition, or we can say mass of the soil solids divided by volume. Mass of soil solids, as you can see, it is equal to 28.5 kilograms. So I'll be substituting the same value over here, 28.5 divided by volume, which is 0.0192 cubic meters. By calculations, this is equal to 1484.37 kgs per cubic meter. All right. So we have calculated dry density as well. Next one. All right. Saturated density. All right. Before calculating the saturated density, if I'll be using this generalized equation G plus E, density of water divided by 1 plus E, for that I must be knowing this value, the void ratio. Now to arrive at void ratio, I'll be using the generalized equation for the dry density. Because I already have a value, I can use either of dry density or the bulk one. But in this question, let me use dry density. It is G rho W divided by 1 plus E. My aim is to find void ratio before finding out the saturated density. All right. So dry density, as I have already calculated, it's 1484.37 kgs per cubic meter. I'll be substituting the same value over here, 1484.37. G, we have been asked to use how much? Let me get back to the question. Take specific gravity of solids is 2.65. 2.65. Density of water, 1000 kgs per cubic meter divided by 1 plus E. Upon calculations, E comes equal to 0.785. That means void ratio is 0.785. All right. Now, the saturated density, I'll be using the same equation. Saturated density is G plus E rho of water 1 plus E. That means G 2.65 as per the data given in the question. Void ratio is 0.785. Density of water is 1000 divided by 1 plus 0.785. Upon calculations, the saturated density is equal to 1924.36 kgs per cubic meter. All right. So I have calculated saturated density as well and void ratio before even calculating the saturated density. So the only two things that now are pending is this porosity and degree of saturation. Now let's find them as well. All right, I'll be rubbing this much. Porosity and the degree of saturation. These are the last two parameters which we need to find out in this question. All right. As we know the value of void ratio, we can easily find the porosity. Porosity, as you know, it is equal to E divided by 1 plus E. Void ratio was how much? 0.785 divided by 1.785. Upon calculation, it comes equal to 44%. All right. So the porosity is equal to 44%. Now the only thing that's left is the degree of saturation. Degree of saturation, will be finding it by using this equation with the help of ES is equal to WG. That means S is WG divided by E. W is how much? Water content. We did find it 12.28%. That means 0.1228 multiplied by G 2.65 E 0.785. By calculations, degree of saturation is equal to 41.45%. All right, so that's how we calculated each and every parameter from the data as was given in the question. All right, we completed all the parts. We found bulk density, water content, dry density, saturated density, void ratio, porosity, and degree of saturation as well. Moving on to the next question. See, we are trying to solve as many numerical questions as possible for this topic of geotechnical engineering, that is weight volume relationships. All right. All right, so this is the next question. Question is question number 13. A sample of saturated soil has a water content of 25% and a bulk unit weight of 20 kilonewton per cubic meter. Determine the dry unit weight, void ratio, and the specific gravity of solids. What would be the bulk unit weight of the soil if it's compacted to the same void ratio but has a degree of saturation of 90%? All right, so this is the numerical question. So let's solve it. So as we can see, question is divided in two parts. First, we have to determine the dry unit weight, void ratio, and the specific gravity of the solids. So let's go on finding them. The data given is that the water content is 25% and the bulk unit weight is 20 kilonewton per cubic meter. All right. So let's first solve the part 1 of the question. Bulk unit weight as given in the question is 20 kilonewton per cubic meter. Water content is 25%. Question in the first part says me or asks me rather to calculate the dry unit weight. All right. I'll be using this thing rather than this. All right. Dry unit weight and the bulk unit weight. All right. So now I have to find the dry unit weight, which is given by this relation. Dry unit weight is bulk unit weight divided by 1 plus water content. So dry unit weight is, how much is the bulk unit weight? It is 20 kilonewton per cubic meter divided by 1 plus water content, that is 0.25. All right, because water content is 25%. Upon calculating this, dry unit weight is equal to how much? 16 kilonewton per cubic meter. All right, I use the equation which relates the dry unit weight with the bulk unit weight and the water content. So the answer for dry unit weight is, I have used W, rather it's D. All right, so the dry unit weight is 16 kilonewtons per cubic meter. All right, what else does it ask? It asks determine the dry unit weight, void ratio, and the specific gravity of solids. So let's now find the void ratio. Void ratio, if I'll be using this equation, it is equal to the generalized equation. S is equal to Wg. But if you see, the question itself says a sample of saturated soil. So in this condition, soil is completely saturated. All right, so there is no air phase. So S is equal to 1. So E is equal to Wg. E is equal to, water content is how much? 25%. And G, that is to be found out. We don't know G. This becomes equation. Let's suppose 1. Also, as we have calculated this thing, the dry unit weight, 16 kilonewton per cubic meter, we will be using the same relation for the dry unit weight to go on finding the void ratio. We know that dry unit weight is equal to G 1 plus E. I don't know why I'm using subconsciously W instead of D. All right, so let's substitute the values. It's 16. G we don't know. Unit weight of water 1000 kilonewton per cubic meter, 10 kilonewton per cubic meter divided by 1 plus E. E will be substituting this value 0.25 G, as we calculated from the equation number 1. We'll be using the same value over here. Now upon calculating, G is equal to 2.667. That means we have found out the value of specific gravity of solids as well. This part is also completed. G is how much? It is 2.667. Now from equation 1 we can find out the void ratio. Void ratio is 0.25 into G. G is how much? 2.667. So void ratio is 0.667. All right. So we have completed the part 1 of this question, as we have found out dry unit weight, void ratio, specific gravity of solids. All right. Now the part 2 of the question says, what would be the bulk unit weight of the soil if it's compacted to the same void ratio but has a degree of saturation of 90%. All right. So let's now solve this question, this part of this question. Bulk unit weight is given by this equation, G plus SE divided by 1 plus C. All right. So this is G, as we have calculated, 2.667 plus S, degree of saturation 90%, degree of saturation is 90%. E we also calculated 0.667 multiplied by unit weight of water, 10 kilonewton per cubic meter, divided by 1 plus E. E is how much? 0.667. That means 1.667. All right. Upon calculating, this is 19.90 kilonewton per cubic meter. All right. This is the bulk unit weight. Part B of the question is complete as well. What would be the bulk unit weight of the soil if it's compacted to the same void ratio but has a degree of saturation of 90%? The bulk unit weight of the soil, if it's compacted to the same void ratio but has a degree of saturation of 90%, is 19.60 kilonewton per cubic meter. All right. So this was about this question. Moving on to the next one. Question is, the mass of an empty gas jar was this much when completely filled with water. Its mass was 1.528 kgs. An undried sample of soil of mass 0.198 kgs was placed in the jar, and the water was added to fill the jar, and its mass was found to be 1.653 kgs. We have to determine the specific gravity of the particles. Alright, so this is the question and we'll be solving this. As is evident from the data as given in the question, this question is based upon the gas jar method for the determination of the specific gravity of soil solids. Alright, and in this gas jar method, a gas jar of about 1 liter capacity is used, and this jar is fitted with a rubber bung. And this gas jar, in this case, it serves as a pycnometer, and the method is very similar to the pycnometer method for the determination of the specific gravity of the soil solids. All right, but this method is known as the gas jar method, and we'll be using the same generalized formula for determination of the specific gravity of the soil solid particles as is used in the standard pycnometer method, and we'll be finding out the specific gravity. All right, as we know, specific gravity is given by m2, this is the generalized equation, minus m1 of the pycnometer method, m3 minus m4. There is no as such difference between the gas jar method for the determination of the specific gravity of the soil solid particles or with the pycnometer method. In this case, when we use the gas jar method, a 1 liter capacity jar is used, which serves as a pycnometer. All right, rest is same. Here in this equation, m1, it is the mass of empty bottle, M2, this is mass of bottle and dry soil. And dry soil. Then we have M3. It is mass of soil, bottle and water. Bottle and water. And M4, it is mass of bottle filled with water. This is mass of bottle filled with water. Alright, so let's see what's given in the question, and accordingly we'll be having our M1, M2, M3 and M4. M1 is the mass of empty bottle. The mass of an empty gas jar was 0.498 kgs. This is our M1. 0.498 kgs. M2. M2 is mass of bottle and dry soil. When completely filled with water, its mass was 1.528 kgs. Alright. An undried soil sample of mass 0.198 kgs was placed in the jar. Now M2 is mass of bottle and dry soil. Mass of empty jar is 0.498 kgs. When an oven dried soil sample of soil of mass this was placed in the jar, that means this plus this is M2. M2 is 0.498, which is the mass of the empty bottle or jar plus dry soil, because it's very well given in the question itself. Then when oven dried soil sample was placed, that was how much? That was of weight 0.198 kgs plus 0.198 kgs. This is 0.696 kgs is M2. M3, mass of soil, bottle and water. Alright. An oven dried sample of soil of mass this much was placed in the jar and water was added to fill the jar, and its mass was found out to be 1.653 kgs. That means mass of bottle, mass of soil, bottle and water is how much? It is 1.653 kgs. So M3 is 1.653 kgs. Now the only thing that is remaining is M4, that is mass of bottle filled with water. How much is that? That is this much. Read carefully. The mass of an empty gas jar was found out to be 0.498 kgs. When completely filled with water, its mass was 1.528 kgs. That means mass of bottle filled with water is 1.528 kgs. M4 is 1.528 kgs. I have all of them, M1, M2, M3 and M4. I'll be substituting them in the general equation and I'll be finding out the value of G. So M2 minus M1, divided by M2 minus M1, minus M3 minus M4. Alright. Upon calculations, G is equal to 2.71. Alright. By calculations, volume, the specific gravity of the soil solid particles came equivalent to how much? 2.71. So this was how we used the data as they had taken from the gas jar method for the determination of the specific gravity of the soil solid particles, and this method is very much similar to the picnometer. The only difference is that in this case, the gas jar, which is of about 1 liter capacity, that is used, and that is fitted with a rubber bung. And in this gas jar method of determination of the soil specific gravity of the soil solid particles, this gas jar, this serves as a picnometer. Rest everything is same. We have used the same generalized equation as we use for the picnometer method for the determination of the specific gravity of the soil solid particles, and we found it to be equivalent to 2.71. So this was about this question. Moving on to the next one. All right. Question is, a sample of soil has a volume of 65 milliliters and it weighs 0.96 newtons. After complete drying, its weight reduces to 0.785 newtons. If the specific gravity of soil solid particles is 2.65, determine the degree of saturation. Let's solve this one. All right. Volume of soil sample is 65 milliliters and it weighs how much? 0.96 newtons, bulk unit weight. All right, this is the weight. Then weight when it's dried in dry condition, it is how much? After complete drying, its weight reduces to 0.785 newtons. 0.785 newtons. All right. If the specific gravity is this, we have to determine the degree of saturation. But for determining this degree of saturation, we must be knowing certain parameters like void ratio and what else? Water content. So first we'll be finding the water content. Water content, as you can say, it is equal to this minus this, the total weight divided by the weight minus weight after drying divided by this weight of the soil solid particles. Upon calculation, this is equal to 22.29%. All right, so this is the water content. Then I'll be using the dry unit weight. That is how much? Weight in the dried condition, 0.785 divided by volume. Upon calculating, it comes equal to 0.01207 Newton per milliliter. But we also know one more equation. This dry unit weight is G, right, divided by 1 plus E. I'll be substituting this value over here. It is 0.01207. Specific gravity, as it's given in the question, we have to use it as 2.65. All right, 2.65 multiplied by density of the water. All right, unit weight of water, that is 9.81 kilonewton per cubic meter. All right, so that is 0.00981 Newton per ml divided by 1 plus E. Upon calculations, E is equivalent to 1.145. Now we'll be using this relation ES is WG and we'll be finding the degree of saturation as the question demands. So S is WG divided by E. So S is water content 22.29%. specific gravity 2.65, void ratio 1.145. By calculation, degree of saturation is equal to 51.58%. So this is how we solved this question. We first found the water content, then the dry unit weight. Once again, I don't know why this happens. Subconsciously, I just write W instead of D. Dry unit weight, it is how much? 0.012207 Newton per ml. Then I use one more relationship for the same dry unit weight, and I found void ratio, which is equal to 1.145, and then subsequently the degree of saturation, which came equivalent to 51.58%. Moving on to the next question. All right. A saturated soil sample has a water content of 40%. If the specific gravity of solids is this, we have to determine the void ratio, saturated density, and submerged density. Let's solve this one. A saturated soil sample, that means S is 1, has a water content of 40% and specific gravity is given 2.6, and we have to determine the void ratio, saturated density, and the submerged density. Let's find the void ratio first. As S is 1, we'll be using this equation. ES is equal to WG. That means E is equal to WNG. E is 0.40, 40% is the water content, and G is 2.67. Upon calculating, E is equal to 1.068. So approximately I can take it as 1.07. So the first part is completed. We have found out the value of void ratio. Now we have to find the saturated density. Saturated density, as you can say from the generalized equation, it is G plus E rho W divided by 1 plus E. Alright, so let's go on substituting the values. Saturated density, G is 2.67, E is 1.07, density of the water 10 kilonewton per cubic meter, divided by 1 plus E, that means 2.07, 1 plus 1.07. Upon calculating, this is equal to 18.06 kilonewton per cubic meter. Second part is also completed. Submerged density is the last thing that we need to find, and from the generalized equation, the submerged density is equal to G minus 1 plus E. These equations are all valid for S is equal to 1 because it's very well given in the question that it is a saturated soil sample. There is no air phase. Soil is completely saturated. Alright. So this is how much? 2.67 minus 1. Density 10 kilonewton per cubic meter. 1 plus 1.07. By calculation, submerged density is equal to 8.067 kilonewton per cubic meter. Right? So we completed the question in all respects. We did find void ratio, saturated density, as well as the submerged density. It was quite an easy question. Now let's move on to the next one. Next question is, a partially saturated sample of a soil has a density of 1950 kgs per cubic meter and a water content of 21%. If the specific gravity of solids is 2.65, calculate the degree of saturation and void ratio. If the sample gets subsequently saturated, calculate its saturated density. So again, question is divided into two parts. Now let's first solve the part A. Alright, the data as given in the question is, a partially saturated sample of a soil has a density of 1950 kgs per cubic meter. That is the bulk density, because soil is partially saturated. All right, and a water content of 21%. If the specific gravity of the soil solids is 2.65, we have to calculate the degree of the saturation and the void ratio. All right, so let's do this. We know that dry density is bulk density divided by 1 plus water content. We know the bulk density 1950 kgs per cubic meter. Water content is 21%, 1 plus 0.21. By calculations, the dry density is 1611.57 kgs per cubic meter. We'll use the alternate equation for the dry density because our aim is to find the void ratio. I'll be substituting this value over here, 1611.57. G as given in the question is 2.65. Density of water 1000 kgs per cubic meter, 1 plus E. Upon calculating, E is 0.644. Question says calculate the degree of saturation and void ratio. Void ratio we have calculated 0.644. Now we have to calculate the degree of saturation. We'll use this equation. ES is equal to WG, S is equal to W. G divided by E, water content is 21%. G is 2.65 and E we just found its value 0.644 upon calculations. Alright, upon calculations, degree of saturation is 86.41%. So part A of the question is complete. We found the values of degree of saturation and void ratio as well. Part B says if the sample gets subsequently saturated. First it was partially saturated. Now if the sample gets subsequently saturated, calculate its saturated state. All right. When the sample gets subsequently saturated, S becomes 1. Now we can use a generalized equation which will become G plus E, 1 plus E, because the sample subsequently got saturated, S became 1. All right, and now we'll be using the equation for the saturated density, which is G plus E, rho W divided by 1 plus E. Will be substituting the values and we'll be having the answer. G 2.65, E 0.644, density of water 1000 kgs per cubic meter, 1 plus E. Upon calculations, the saturated density is equal to 2003.64 kgs per cubic meter. Alright, so this we also found out. So part B of the question is complete as well. If the sample gets subsequently saturated, calculate its saturated density, which came equivalent to 2003.64 kgs per cubic meter. Alright, moving on to the next one. Alright, we have been given certain data and we have to find a lot of parameters. Question is, a sample of a soil has a volume of 1 liter and a weight of 17.5 newtons. The specific gravity of solids is 2.68. If the dry unit weight of the soil is 14.8 kilonewton per cubic meter, determine water content, void ratio, porosity, saturated unit weight, and submerged unit weight, as well as the degree of saturation. All right, so let's find the values for all the parameters that the question asks or demands us to find. All right, so a sample of a soil has a volume of 1 liter. All right, and a weight of 17.5 Newton, bulk unit weight. How much? It is 17.5. This is weight. How much? 17.5 Newton, right? Bulk unit weight. Bulk unit weight is weight per unit volume. That is 17.5 divided by 1. That is 17.5 Newton per liter. This is the bulk unit weight, which is equivalent to 17.5 kilonewton per cubic meter. Alright. We also know that dry unit weight is bulk unit weight 1 plus water content. Dry unit weight is how much? It is given in the question. If the dry unit weight of the soil is 14.8 kilonewton per cubic meter, that means dry unit weight is 14.8 kilonewton per cubic meter. Bulk is 17.5. Water content will be having by this equation, and it is equal to 18.2%. So the first part of the question is complete. We very well found the value of water content, which came equivalent to 18.2%. Our next aim and goal is to find the void ratio. Alright, now we'll be using one more equation for the same thing, that is dry unit weight. This is G dry unit weight 14.8. Specific gravity, as per the data we have to use 2.68. This is 10 kilonewton per cubic meter. 1 plus E. Upon calculating, void ratio is 0.81. Next parameter done. Now porosity. When we know the void ratio, we can very easily find the porosity. Porosity is E divided by 1 plus E. So porosity is E is how much? 0.81 divided by 1.81. By calculations, that is equivalent to 44.7%. The next thing that question demands us is, this is done, water content is done, void ratio is done, so is the porosity. Now saturated unit weight. Saturated unit weight is G plus E, unit weight of water, divided by 1 plus E. Saturated unit weight is 2.68 as per the data. E we found out 0.81 divided by 1.81. Unit weight of water is 10 kilonewton per cubic meter. Upon calculation, saturated unit weight is 19.28 kilonewton per cubic meter. Alright, so this is done as well, saturated unit weight. Now we have to find the submerged unit weight, and then subsequently the degree of saturation. That is the last parameter that we need to find. Submerged density Alright, submerged density is G minus 1 density of water divided by 1 plus E. Submerged density is 2.68 minus 1 density of water How much? 1000 kgs per cubic meter divided by 1.81. 1 plus 0.81. 0.81 is the void ratio. Upon calculations, the submerged density is equal to 928.17 kgs per cubic meter. Alright, so this is done as well. The last thing that we need to find is the degree of saturation. The degree of saturation will be using the generalized equation. ES is equal to WG. S is equal to W divided by E. S is equal to water content. How much? 18.2%. Zero 0.182, specific gravity 2.68, and the void ratio 0.81. Upon calculating, S is 60.21%. So we have completed all the parts of the question. We have found out water content, which came equivalent to how much? 18.2%. Void ratio, it was 0.81. Porosity, 44.7%. Saturated unit weight, 19.28 kilonewton per cubic meter. Submerged density, 928.17 kgs per cubic meter. And degree of saturation, 60.21%. So we have completed this question completely. All right. We have found all the parameters: the water content, void ratio, porosity, saturated unit weight, submerged density, as well as the degree of the saturation. All right. Moving on to the next one.